Question 31. The diagram shows a glacial landscape feature forming over time from a melting block of ice. So they show you three parts. The ice is dropped from a glacier and it lands on the land. After a long period of time, it melts and its weight pushes its way into the sediment. So it becomes surrounded by sediment. Then after a while it melts. And when it melts inside the sediment, it becomes like a lake. We call it a kettle lake. So this glacial landscape feature is best identified as a kettle lake, because a kettle lake is when a block of ice is pushed, when it hits the ground, when it falls from a glacier, hits the ground, and it pushes its way through gravity into the ground and it melts. That's what usually makes a kettle lake. So the correct answer for question 31 is answer 1. Question 32. The block diagram below shows a landscape region. Which stream drainage pattern will most likely develop at the surface of this region? Well, we know that if it's a stream drainage, that means it has to be streams, right? So these are three streams, okay? It's going in this direction, it's going down. Now, how it gets in that direction doesn't make a difference. Main thing is we know it's going in this direction, it's going down. It could connect in different ways. It could connect, let's say, from little streams on the side, which it probably is connecting from, till it becomes the big stream at the end, the strongest stream at the bottom. And along the way, there's little streams going into it. And the only answer that shows you straight streams is answer 1. All the other ones are going, answer 2 and 3 show streams going in different direction. It wouldn't create the landscape we see where it's going downwards. So, and answer 4 just shows like streams going in every single direction, doesn't mean anything. The only answer to the question the black diagram below shows. Question 32. The black diagram below shows a landscape region. Which stream drainage pattern will most likely develop at the surface of this region? Well, you see you have three lines over there. You see it's going from higher to lower. And answer 1 is the only one that shows, stream drainage pattern will form like rivers that will take out the water. So we know it should be 1, 2, 3. And it should be connected by little streams in between these ridges, in between the mountains. And the only answer that looks like that is answer 1. So the correct answer to question 32 is answer 1. Question 33. The diagram below shows a laboratory stream table. As you see, there's a piece of wood underneath this long. Question 33. The diagram below shows a laboratory stream table. A mixture of sediment was placed on the stream table. A short time after the faucet was turned on, a deposit of sediment began forming at location X at the lower end of the stream table. So it was going down the stream. Let's say this is the stream, right? Going down over here. There's the water. And there was a sediment mixture that was put over here. Let's say over here. And slowly but surely, the water pushed it out, forming, as you can see, it looks like it looks like a fan. And also, It's large, it's flat, as you can see from the diagram. So we know that when that happens, when a river with the sediment in the middle of the river and it's pushed out and it creates a large flat fan-shaped pile of sediment at the mouth of the stream. This is where the stream is coming out of. The stream is going over it, around it. So that is called the delta. So the correct answer to question 33 is answer 3. That what is the name of the stream feature forming at location X? That's where the sediment was pushed into this area. That the answer is a delta, because the delta is resulting from this landform is a large flat fan-shaped pile of sediment at the mouth of the stream, and that's called a delta, which is answer 3. So the correct answer to question 33 is answer 3. Question 34. The diagram below shows 3 stages in the formation of a specific rock. So the first stage shows you the remains of partially decayed plants, that means plants that died and they're decaying. The next stage is burial produces pressure from overlying sediments. That means more stuff is getting buried on top of these plants, of these dead plants. And then stage 3 is further burial creates more pressure. And it causes so much pressure that these plants become parts of rocks. And we know that that means it's going to be sedimentary rocks. Now, which rock is formed as a result of these 3 stages? Limestone, gneiss, schist, or coal? Well, we know that it's sedimentary. Even if you wouldn't, you could look also at metamorphic in the Earhscience reference tables. So look at the scheme of sedimentary rock identification, look at the comments. And the comments you'll see form at the bottom of the comments, the last line of the comments is from plant remains. That means what rocks that become from plants. And to the right of it, the rock name, right next to the comment, the rock name says coal. So from plant remains, the rocks that could be made from it is coal, which is answer 4. So the answer to question 34 is answer 4, coal. Question 35. The diagram below shows the temperature readings on a weather instrument. And you have a wet bulb and a dry bulb. And if you read on the wet bulb, the dark line stops at 15 degrees Celsius. That means the wet bulb reads 15 degrees Celsius, and the dry bulb, you see, the black line stops at 25. That means the dry bulb reads 25 degrees Celsius. Based on these readings, the relative humidity of air is closest to what? Well, we want to find the relative humidity, so we have to look at the charts they give us on the regions. Like most of the other questions. And you see it says relative humidity, not dew point temperatures. There's one that says relative humidity. So on the top, it shows the difference between wet and dry bulb temperatures. So you know that the difference between 15 and 25 is 10. So go to where it says 10. And we know that the wet bulb temperature is 15, but it doesn't ask us that, just shows us the difference, which is 10, and then it shows over here the dry bulb temperatures. It goes from all the way from negative 20 to all the way to 30 in Celsius. So I just did 16 through 26. So at 24, the difference between wet and dry when it's 1, when the difference is 1, and the temperature, dry bulb temperature, is 24, then it's a relative humidity of 92. If you go all the way down to 10, when it's a difference of 10 between wet bulb and dry bulb, like over here, 15 to 25 is a difference of 10. So, and when it's 24 degrees Celsius, the relative humidity is 30. But the difference we know, the dry bulb temperature is not 24, it's 25. So it's between 24 and 26, there's no 25. So 24 at the difference of 10 degrees, right? The difference of 10 degrees, and the temperature, the dry temperature is 24, the relative humidity is 30. And if the temperature is 26, and at the difference of 10, between wet and dry, the relative humidity is 34. So it's between 30 and 34. Let's see, about 32 degrees, about 32. The difference is about 30, a relative humidity of about 32. So now the question is, based on these readings, the relative humidity of the air is closest to 8 degrees, 11 degrees, 32, which we just said it's around, or 60. So of course, now that you know it's between 30 and 34, the answer is it's closest to 32. It's not closest to 60. 30 and 34 is much further away from 60 than it is from 32. And it's also much further away from 11 and 3 degrees than it is from 32. So the correct answer to 35 is question 3, that the relative humidity is 32 degrees Celsius. Question 36 and 37. Base your answers to questions 36 and 37 on the diagram below, which represents the greenhouse effect in which heat energy is trapped in the Earth's atmosphere. So here's the sun, and here's the shortwave radiation going down from the sun. It hits the Earth's atmosphere, and coming up from the sun is long-wave radiation. Well, we know that the greenhouse gases, speaking about the greenhouse effect, and how it traps radiation from the sun, and we know that greenhouse gases are gases in the atmosphere that absorb and emit radiation within the infrared range. So the question is, question 36, which type of radiation from Earth is the long-wave radiation absorbed by the greenhouse gases? Well, we know it's through infrared, that's how it's trapped. So the answer to question 36 is answer 3. Question 37, the Earth's surface that best absorbs shortwave solar radiation has which characteristics? Well, what absorbs heat the best? If you're out in the sun and you don't want to get too hot, you wear something light, like something white or something. If you want to absorb heat, it's cold outside but the sun's out, you wear a dark jacket. If it's light, you wear a shirt. If it's hot, you wear a shirt, it deflects the light. If it's cold, you wear a jacket, and the light, it absorbs the light. Also, if it's rough, each time the sunlight hits the jacket, first of all, if it's dark, it goes into the jacket, and also if it's rough, if it has like necks that it can't just get deflected, it could bounce around a bunch of times, and each time it knocks against the surface, it gives off a little more energy, and that's why the energy going from the sun is much stronger than the energy after it hits the earth and goes upwards. So the correct answer to question 37, the Earth's surface that best absorbs shortwave solar radiation has which characteristics? Black and rough. Answer 1. Question 38. For questions 38 through 41, on the counter map below, that's this map over here, it shows you a hill, and it shows you different parts of the hill. This is 220 feet high, closer to the middle of the hill is 240 feet high, and then the middle of the hill is 260 feet high, in this circle. So base your answers to questions 38 through 41 on this map, which shows a hill formed by glacial deposition near Rochester. Question 38. Base your answers to questions 38 through 41 on this map. This glacial deposit is best identified as what? Well, it says that this map is a hill with glacial deposition, and letters A through E are just reference points, and these numbers are in feet. That means this outer circle is 220 feet above sea level, and further in, the inner circle is 240, and the inner circle is 260 feet. You see, as you go closer to the top of the hill, the height gets higher. Now, the question is, this glacial deposit is best identified as what? A U-shaped valley? Does it look like a U-shaped valley? A sand dune? Doesn't say anywhere that it's a sand dune. A drumlin? Well, it does look like a drumlin because a drumlin is a mound of glacial debris, and we said it's glacial debris. We said it's a glacial, it's a hill formed by glacial deposition. So that's a drumlin because a drumlin is a mound of glacial debris formed into a smooth teardrop-shaped hill. And this looks like a teardrop. This is the top when the person's crying. Over here I made a picture of someone crying. You see the drops coming down? If you look at it closely, the teardrop looks like this. Let's say in the bottom it's bigger and it gets more together at one point. So this looks like a big teardrop, that the outer part is low, and as you get more to the middle, it's a little bit like a circle, like water. It's a little bit like a circle, like a teardrop falling down. So here's the person with the teardrops, and that's a smooth shaped hill. As you can see, it looks smooth, the hill. And that's a drumlin. So the answer to question 38 is answer 3. Because a drumlin is a mound of glacial debris formed into a smooth teardrop-shaped hill. It is not a sand dune, it's not U-shaped, and it does not look like an outwashed plain. So the only answer to question 38, the glacial deposit is best identified as a drumlin. Answer 3. Question 39. Which description best compares the gradients of the hill? The gradients are how the hill goes down in the levels and the steepness. So they give you 4 answers. AE and EB has the same gradient. Now to figure out the gradients, you also have to figure out the length. How long does it take it to go down? How steep is it? It's gradient is steepness, right? So if you see, E is the midpoint between C and D. So CE and ED are the same. So I made one black line over here. You could see that from the first 2 circles, first 2 ovals, you could see that from E going down to C, it goes down much steeper. And than it does from E to A. Should be an A over here. From AE is not as steep as from DE or CE. So therefore AE is longer than CE or ED. And the longest one from E to B, so I made 3 lines. Now, is AE and EB equal? Is their gradients, their steepness, is it equal? Let's see, what's AE? This is AE. And this is EB. No, they're not the same steep. So we're going to cross that out. Question 39. Which description Question 39. Which description best compares the gradients of this hill? So we know the gradients is the slope. So the question is, they show you points at the end points of this hill and the middle of this hill. A, B, C, D, and E. And they show you again that the outer circle is 220 feet high, more inside is 240, and the inner circle is 260 feet high. So, which description best compares the gradients of this hill? So, all you need is one right answer. AE and EB have equal gradients. Well, gradients means it's slope. What's AE? This is AE. And what's EB? This is EB. Now, do they have the same slope? If it takes longer for it to slope downwards, from AE, it's sloping like this. And from EB, to reach the same slope, it's going like that. So you see, it's a much less of a slope. They don't have the same slope. So answer 1 is not correct. AE and EB do not have the same slope. Let's do answer 2. AE is steeper than line EB? Let's see, AE is steeper than line EB? Yes, it is, because from the circle where the height is 260 feet, going down to 220 is much steeper. It's like this. For A, we'll make it like a triangle. Here's D. This is A. This will be E in the middle. And this is B. So this is D. This is point E. And this is point A. And this is point B. So the question is AE, that's this over here, steeper? That means it goes down faster than EB? The answer is yes, look. See, because AE's thing goes down much faster than from a smaller distance, it's going down much steeper than the distance of E to B. See, it's going, so the correct answer to question 39 is 2. Let's see answer 3. CE is steeper than ED. Let's see. CE is this over here. This over here is CE. Is it steeper than ED? Well, it's the middle point. So that's not correct. Answer 4 is not correct because they're equal gradients, equal steepness. CE and AE have the same gradient. Let's see. CE and AE do not have the same gradient because if you could see on the original regent that that CE is closer to each other. C is closer to E in measurement than E is to A. And also, if you wouldn't have been able to figure it out, then the answer would have not been correct. They wouldn't have even given you that question. So on the region itself, you would have seen that CE is less of a distance. That means it went down to the 220 feet high. From the 260 feet high area to the 220 feet high, it went quicker because there's less area from C to E than it went from E to A. And as you can at least see, that the first two parts went down quicker. So on the region itself, you would see that E to A is longer distance than E to C. And a longer distance, if you have to go from this point to this point, and if you have to do it in a small distance, you have to do it in a longer distance. If you do it in a smaller distance, you're going down a steeper hill. If you do it in a longer distance, you're not going down such a steep hill. So CE and AE do not have the same gradient. So the only correct answer to this question is that answer 2, that AE has a steeper gradient than EB. AE, that's this part over here, it has a steeper gradient than EB does, because EB has a much longer distance to get from 260 feet down to 220. So the correct answer to question 39 is answer 2. Question 40. Which set of characteristics is most likely describes the sediment in this glacial deposit? Well, glacial deposit deposits anything that's in the ice, no matter how big the size, how small the size. So, and it doesn't like if you cook something or if water is washing over something, it deposits. The faster the water, the bigger things it could deposit. As the water slows down, deposits only smaller ones. As it slows down, the bigger ones keep on getting deposited, but the faster it goes, you even have bigger ones that are deposited, like boulders could be deposited as fast as water goes. So that could be sorted out. First, the big rocks stop moving when the water slows down more. The smaller rocks stop moving till it goes so slow that tiny little pebbles and even sand stop moving. So that's called sorted. So since this is by a glacier, so it's unsorted, and since a glacier does not sort big and small rocks, so it's also not layered, because it cannot it cannot. Question 40. Which set of characteristics most likely describes the sediment in this glacial deposit? You have to remember that a glacier carries all different types of rocks, big ones, small ones, and then as it melts, it just falls to the ground. So therefore, it's unsorted, and also most likely it's also not layered. So the correct answer to question 40 is answer 3. Question 41. The hill shown in this map is found in which New York landscape region? Well, from the map itself, I erased that map because the map itself won't tell you any information. But it said beforehand, before question 38, that questions 38 through 41 is you should use this map, and it's in Rochester, New York. So you have